All right, welcome back to another episode of How to Geometry. In this video, we're looking at another special case triangle, the 30, 60, 90 triangle. If you haven't already, check out the video on the 45, 45, 90 triangle. It's a good segue into this particular case as well. Hopefully you can catch on to the pattern and life should be easy. Enjoy. Hey, special right triangle, 30, 60, 90 case now. If you haven't already, go and check out the 45, 45, 90 degree triangle. Very useful. This is the second case or the second type of special right triangle, the 30, 60, 90. So let's start by orienting ourselves to the angles. All right. So here we have our right triangle. Obviously, we have the 90 degree. All right, so we have our 30-degree angle. We have our 60-degree angle. One thing to note, a couple things to note. In this particular case, when you have 30, 60, and 90, there's always going to be two legs and the hypotenuse. Now, in the 45, 45, 90 case, the two legs were always congruent, right? They were always the same. In this particular case, the two legs are going to vary in size. You're going to have a short leg and you're going to have a long leg. Then you're going to have the hypotenuse, which is the longest side, always in a right triangle. But as far as the two legs are concerned, there's a short leg and a long leg. So let's identify that. All right, so the short leg is going to always be across from the small angle. We'll call this the short leg. Or in other words, SL. That's going to be the abbreviation we're going to use. All right, so the long leg is going to always be across from the larger angle, and the short leg is going to always be across from the smaller angle. All right, so let's look at some standard leg lengths and see if we can recognize any patterns that may emerge. All right, so in this case, we're going to be given the short leg and the hypotenuse, and let's try to figure out what the long leg is by using Pythagorean's theorem. Right, recall that Pythagorean's theorem is a squared plus b squared is equal to c squared. Right, the sum of the square of the legs is equal to the square of the hypotenuse. So if a is 1 squared plus b squared is equal to 2 squared, this is going to be 1 plus b squared is equal to 4, b squared is equal to 3, so b is equal, so since we're going to isolate b, we got to take the square root of both sides. So this is going to be b is equal to root 3. So here we have root 3. Now let's try another one and see if we can come up with some sort of pattern. Maybe we'll see it on the next one. All right, so here we're given the short leg is 2 and the hypotenuse is 4. Let's figure out what b is. This is going to be 2 squared plus b squared is equal to 4 squared. 4 is equal to b squared, which is equal to 16. We're subtracting 4 from both sides of the equation. B squared is equal to 12. Taking the square root, we see that b is going to be equal to root 12. 12 is really 4 times 3. So the 4 is going to come out as a 2, right? Because 4 is a perfect square. So 2 root 3. So b is going to be 2 root 3. I feel like we can make a pretty good prediction on what the pattern is going to be. But let's see one more example, and I think that'll solidify what the pattern actually is. Okay, here we have the short leg is 3, and the hypotenuse is 6. So again, applying Pythagorean's theorem, we're going to get the short leg, which is 3 squared, plus b squared, which is equal to the hypotenuse 6 squared. 9 plus b squared is equal to 36. Subtracting 9, b squared is equal to 27. Root 27 can be simplified into 3 and 9, and then 9 to 3 and 3. So 3 is going to come out. So b is equal to 3 root 3. Okay, I think this is sufficient to make a hypothesis on what the pattern is going to be, right? So Here we have, in the first example, the short side is 1 and hypotenuse is 2. So the relationship there is the hypotenuse is 2 times the short leg. The long leg is the short leg times root 3. Let's see if that's true in the second case. So again, the hypotenuse is double the short leg, and the long leg is root 3 times the short leg. And the third example, the pattern continues. The hypotenuse is double the short leg, and the long leg is root 3 times the short leg. So let's write these down. Hypotenuse is equal to the short leg times 2. The long leg is going to be the short leg times root 3. So here, knowing what the short leg is pretty important. No, you're not always going to be given the short leg. You're going to be given one of the 3, and then you're going to have to be able to figure out what the other 2 are. And there is a really good process, which I'm about to show you right now. Okay, so a good little diagram for figuring out the legs in a 30, 60, 90 triangle are as follows. Okay, so if I have the short leg and I want the long leg, we're going to multiply the short leg by root 3. And if I have the long leg and I want the short leg, we're going to do the opposite operation. And we're going to divide the long leg by root 3. All right, if I have the short leg and I want the hypotenuse, I'm going to multiply by 2. And if I have the hypotenuse and I want the short leg, I'm going to have to divide the hypotenuse by 2. So again, if I have the short leg, I can get to the long leg and the hypotenuse. If I have the hypotenuse, I can get to the short leg and then to the long leg. And if I have the long leg, I can get to the short leg and then the hypotenuse. So yeah, this chart here is pretty good. Probably commit this screen to memory. If you're taking any kind of notes, this would definitely be worth writing down. All right, so let's see some examples. All right, in the first example, we have 30, 60, 90 right triangle. And we're given the short leg, mainly because it's across from the small angle. So that's how we know it's the short leg. So I can figure out the long leg and the hypotenuse from here. Now let's just do long leg. So the long leg is going to be the short leg times root 2. The long leg is going to be the short leg times root 3. So in this case, y is equal to 8 root 3. The hypotenuse is 2 times the short leg. So here we have the hypotenuse is going to be 2 times 8, which is 16. Okay, another example we have the short side, which is going to be across from the smaller angle, is 9. So the long leg is going to be equal to short leg times root 3. So here we have the long leg is equal to 9 root 3. Hypotenuse is going to be 2 times the short leg. So the short leg is 9 times 2, we'll have 18. All right, let's do another example. In this particular example, the hypotenuse is 22. We know that if we have the hypotenuse, we can always get to the short leg by dividing by 2. So short leg is equal to hypotenuse divided by 2. 22 divided by 2 gives us 11. So the short leg is going to be 11. The short leg is across from the small angle. And then the long leg is equal to short leg times root 3. So in this case, 11 root 3. All right, in this example, again, we're given the hypotenuse, which is 46. And to get from the hypotenuse, first place we go is the short leg. So short leg is going to be hypotenuse divided by 2. 46 divided by 2, 23. The short leg is across from small angle. And the long leg is going to be the short leg times root 3. 23 root 3. Okay, we're given another hypotenuse. So short leg is going to be the hypotenuse divided by 2. So short leg is equal to hypotenuse divided by 2. So 10 divided by 2, short leg is going to be 5. So in this case, across from the small angle, which is x, the short side, is 5. The long leg is going to be short leg times root 3. Here we have 5 root 3. So y is equal to 5 root 3. Okay, here's our first example where we're given the long leg. So the long leg, we can get to the short leg next. So get to the short leg from the long leg, we're going to divide the long leg by root 3. So short leg is equal long leg divided by root 3. We have 21 root 3 divided by root 3, and the root 3's are going to cancel, and the short leg is just 21. Get to the hypotenuse, we're going to multiply 2 times the short leg. This is going to be 2 times 21, which is 42. The hypotenuse is 42. Okay, here's another long leg situation. So this is going to be short leg first. So the long leg is equal to, or short leg is equal to the long leg. The short leg is equal to long leg divided by root 3. So 6 root 3 divided by root 3, we have 6. Short leg, in this case, x is 6. And the hypotenuse is going to be 2 times the short leg. So 2 times 6, which is 12. Okay, so I think it's safe to say that in general, when you can recognize that you are in a 30, 60, 90 triangle situation, then this little schematic here will always apply, right? The short leg is always going to be across from the smaller angle, and whatever that number is, the long leg, which is the other leg, across from the larger angle, across from 60, will be short leg times root 3. And the hypotenuse is always 2 times the short leg. So hopefully you got something out of this. If you haven't already, please subscribe. I'm trying to get my subs up. And like, comment, let me know what you think. So hope you all enjoy, and I'll catch you in the next video.